Good afternoon friends, I am Professor Y.D. Shahakar. Today we are going to discuss nonlinear programming. So very first, what do you mean by nonlinear programming? There are various optimization techniques are available like nonlinear programming, linear programming, integer programming, quadratic programming, dynamic programming, etc. All these optimization techniques are used to find the optimum solution for a given problem. Basically, nonlinear programming is the process of solving an optimization problem of equalities and inequality constraint having a set of unknown variables along with the objective function that we have to maximize or minimize. It deals with the optimization problem where the objective function or some of the constraints are nonlinear. So what do you mean by nonlinear constraint? So nonlinear constraint consists of ratio of variable, trigonometric term and square terms, etc. Next is the unimodal function. The name indicates that uni means one, means the function having only one maximum value or only one minimum value in the given interval. Suppose a function f of x is unimodal if first is x1 less than x2 less than x star implies that f of x2 less than f of x1, and second is x2 greater than x1 greater than x1 implies that f of x1 less than f of x2 where x star is the minimum point. So these are some examples of unimodal function. So in the given figure, x is the variable, f of x is the objective function, a and b is the interval, and x1 and x2 are the 2 points which is given in the interval a to b. Now consider the normalized interval that is 0 to 1 and the two function interval as shown in figure. So outcome of the first two experiments are given. So in first figure, f of x2 greater than f of x1, in second figure f of x1 greater than f of x2, and in third figure f of x1 is equal to f of x2. So in first figure interval is 0 to 1, f of x2 is greater than f of x1. So here we have to discard the part x2 to 1 that is greater, means remaining interval is 0 to x2. In second figure again same interval is given, that is 0 to 1. Here f of x1 greater than f of x2 means here we have to discard the part x1 to 0. Then the remaining interval is x1 to 1. And in third figure f of x1 is equal to f of x2 means we have to discard x1 to 0 and x2 to 1. Then the remaining interval is x1 to x2. Now next is the nonlinear programming methods. So there are various nonlinear programming methods are available. So some are the elimination method and some are the descent method. In elimination method there are three main types of method. First is the unrestricted search method. Again in that there are two types. First is unrestricted search with fixed step size, unrestricted search with accelerated step size. Second method is the Fibonacci search method, and third method is the golden section method. So all these are the elimination method. Next are the descent method. In descent method, first is the steepest descent method. It is also known as Cauchy method. And second is the conjugate gradient method. It is also known as Fletcher-Lewis method. So first we will see elimination method. In elimination method, most of the practical problem, the restricted ranges are not given. So in this case, it is not possible to find the exact optimum solution. So we have to find the search direction for getting the optimum solution. For that we have to use the unrestricted search method having fixed step size and accelerated step size. So first is the unrestricted search method with fixed step size. So this method is a very simple to implement and the step size used in this method is very small. Again, when we solve the problem by using unrestricted search method with fixed step size, so here we have to only add the step size. So for that first we have to prepare one table. In that table we have to write the iteration number, after that xi, after that f of xi, and after that condition, that is if f of xi greater or less than f of xi minus 1. Again this condition depends upon the given objective function. If objective function is maximization, then we have to check the condition if f of xi less than f of xi minus 1. If it is minimization, then we have to check the condition f of xi greater than f of xi minus 1. So for that first we have to write a iteration number 1. After that starting point we have to write, that is xi which is given in the problem. After that find f of xi, means put the value of xi in the objective function, then we will get the f of xi. After that we have to check the condition f of xi greater or less than f of xi minus 1. If it is yes, write yes. If it is no, then write no. Similarly for second iteration, only we have to add the step size. That is, suppose starting point is 0 and step size is 0.1, then we have to add 1 by 1, that is 0.1, 0.2, 0.3. For that we have to find the values of f of xi. And lastly we have to check the condition, this is satisfied or not. When the condition is satisfied, then at that iteration we got the optimum solution. Suppose we are continuously solving the iteration, even if we are not getting the optimum point, then we have to stop the problem up to the 10th or 15th iteration. And finally we have to write the optimum point if we got the solution in 9th and 10th iteration suppose. Then we have to write the optimum point of 9th iteration, that is x is equal to dash dash dash. Then finally put that value of x in objective function, then we will get the optimum value. Again in fixed step size, when we use the condition, that is f of x1 less than f of x2, f of x2 less than f of x1, and f of x1 is equal to f of x2. So we have to check that condition. If this condition is satisfied, then go to the next step. Next is the unrestricted search with accelerated step size. Again the fixed step size and accelerated step size, these are the exactly same. Only in accelerated step size we have to take the double of that. Remaining procedure is exactly same. Now this is the theoretical part of unrestricted search method of fixed step size and accelerated step size. Now we will see the numericals on unrestricted search method. So first numerical is find the minimum of the function, that is minimize f is equal to x into x minus 1.5 using unrestricted search method, starting with x is equal to 0 and taking fixed step size of 0.1. So in figure, in problem it is given that minimize f is equal to x into x minus 1.5, starting point x is equal to 0 and step size is 0.1. So first prepare one table, in that write down serial number or iteration number, after that xi, after that f of xi, after that write the condition if f of xi greater than f of xi minus 1. So this condition depend upon the given objective function. So here given objective function is minimization, that's why here we have written the greater than. If given objective function is maximization, then we have to write here less than. So for first iteration, xi means the starting point which is given in the problem. So this is 0, write here 0. After that f of xi means put that value of xi in the given objective function, then we get f of xi. After that check the condition, if satisfied write yes, if it is not then write no. For second iteration simply we have to add the step size, that is 0.1. Similarly find out the value of f of xi and again check the condition. Again for third iteration, again add the step size, that is given 0.1, so 0.2 plus 0.1, 0.3. Again find out the respective value of f of xi, again check the condition. So at 10th iteration our condition is satisfied, means f of xi greater than f of xi minus 1. So write here s, and finally we have to find the optimum point. So here when we check the condition, so for that we have to consider above value and below value. So here when we find the optimum point, so we have to take the above point, that is x is equal to 0.8, and finally we get the solution, that is f minimum is equal to minus 0.56. So this is the first problem of unrestricted search having fixed step size. Similarly second problem, same again, maximize f is equal to x into 1.5 minus x, starting with x is equal to 0 with an initial step size of 0.05. So again maximization is given, so we have to check the less than condition, but here initial step size is given. Initial means we have to consider the accelerated step size. So accelerated step size means simply we have to add in the starting point, after that take the double of that. So for first iteration initially 0 which is given, after that find out f of xi, after that check the condition. Similarly for second iteration add that step size, that is 0.05, find out the respective values of f of xi, again check the condition. For third iteration we have to take the double of that, that is 0.05, after that 0.10, 0.20, 0.40. So in seventh iteration condition is satisfied. So our optimum point is x is equal to 0.80 and the optimum solution is f max is equal to 0.56. Now in third problem, find the maximum of the function f of x is equal to x by 2 for x less than or equal to 2 and f of x is equal to minus x plus 3 for x greater than 2. Here x is equal to minus 1.0 and s is equal to 4. So it is not given fixed step size or accelerated step size. So you can solve by using any one, fixed or accelerated. So here we will solve the problem by using fixed step size. So in that again two objective functions are given. So in this case if there are two objective functions, then which function we have to consider? So for that check your function is maximization or minimization. So given function is maximization, that's why here we have to consider x by 2 because second objective function is minus x plus 3. That's why here we have considered x by 2. Now remaining procedure is exactly same. Again iteration number xi, f of xi and f of xi less than f of xi minus 1. Again here we have taken less than condition because function is the maximization type. So in similar way we have to take the number of iteration. After solving that, for first iteration starting point is minus 1, so write here minus 1, find out the f of xi, again check the condition. For second iteration add that minus 1.0, add that step size, that is s is equal to 4, then minus 0.6, again find out the respective values of f of xi and check the condition. At ninth iteration here our condition is satisfied. So optimum point is x is equal to 1.8 and the optimum solution is 0.9. So in this way we have to solve the unrestricted search method by using fixed step size and accelerated step size. So next part we will see in next session. Thank you.